Hi everyone, welcome to my channel. Welcome to another video of C++ functions. In this video I wanted to talk about return statements and return types of a function. And also, if you're a beginner at C++, make sure to check out my C++ for Beginners course. There you can find very useful examples in order to start learning C++. And also subscribe to my channel and click that bell icon so that you are notified when I publish new video. And if you want to become a developer and you really want to get a perspective into what is the job of a developer and how developer life looks like, make sure to follow me on my other social media platforms, so Instagram and Twitter accounts at CodeBeauty, and I'm going to put those in the description of this video. So without further ado, let's start with today's video. So as I said, in this video I want to talk about return types of a function. So what is return type of a function? Well, a return type of a function can be any data type that can be used in order to declare a variable. So it can be int, float, bool, char, double. It can be any user-created data type, and it can be void as well, which means that that function is not going to return anything. And as we explained in one of my previous videos, function is a block of code. It is a code that is grouped together, and that code is going to perform a specific task. And here I want to make a difference between functions that return value and functions that don't return value. And functions that don't return value can be, for example, an example of a function that does not return value can be a function that writes out a menu to your user. So you call that function writes out a menu to your user, and the job of that function is done there. So you are not expecting any value to be returned from that function. But an example of a function that returns a value can be a function that performs a specific calculation, let's say on arguments that you pass to that function, and after that calculation is performed, you are expecting a certain value, so result of that calculation, to be returned from that function. And an important thing is that function can return only one value, so only one return statement inside your function is going to be executed, and I'm going to show that on the example that we are going to do in this video. And now I'm going to show you really how functions make your code easier to read, easier to understand, and how they make your code reusable. So we are going to show that on an example, which we are going to first make without using function. So we are going to make a program that is going to determine whether a number is prime number or not, and we are going to do that first without using functions, and then I'm going to refactor that program so that it uses functions, and then I'm going to show you how that program becomes instantly more readable, more understandable, and also how that makes your code reusable. So as I said, we are going to create a program that is going to determine whether our number is prime number or not. And the definition of a prime number is a number that is divisible only by itself and by 1. So if that number is divisible by any other number, so not 1 and not itself, but any other number, that means that that number is not prime number. So the first thing that I'm going to do here is I'm going to declare a variable of type int, call it number, and then I'm going to let my user enter that number. So I'm going to write out the message to my user and then use the cin command in order to get that number and store it in my number variable. And then let's explain the algorithm that we are going to use in order to determine whether that number is prime number or not. The definition of a prime number is a number that is divisible only by 1 and by itself, which means that if you can find any other number besides 1 and that number itself that you can use to divide it by this number that our user has entered and get the remainder of 0, that means that this number is not prime number. So how we are going to solve this problem? Well, we are going to iterate through all the numbers between 2 and this number minus 1, and then we are going to check whether this number is divisible by that counter value. So I'm going to write out for int I is equal to 2, and then I is less than number, and in each iteration I want to increase the value of my I counter. So why haven't I used 1 here, and why haven't I said here that this I is less than or equal to the number, because every number can be divided by 1, so we do not need really to check that. And also every number can be divided by itself, and we do not need to check that as well. So here we are going to iterate through this interval, so between 2 and while I is less than that number that our user has entered. And here we are going to check whether this number that our user has entered can be divided by any value of our I, so in any iteration which we are going to go through. And in the situation where it can be divided, we are going to use a flag, which I'm going to declare here. And that flag is going to be of type bool, and let's call it isPrimeFlag, like this, okay? And this flag is initially going to be assigned a value of true. So we are going to initially say that all the numbers are prime numbers, and then we want to prove that wrong for the numbers that are not. So we are going to use this flag in a following way. Here I'm going to check in each iteration if our number that our user has entered can be divided by that current counter, so by the current value of I. So I'm going to use this modulo operation, and I'm going to say if this number modulated by I is going to give us the result of 0. So when you divide this number by I, do you get the remainder of 0? And if this operation here results as true, we are going to say that our isPrimeFlag is going to be false. So we are going to assign the false value to our isPrimeFlag because we have clearly found one number which is not 1, and that number itself that can be used in order to make this condition true. So here I'm going to write out isPrimeFlag, and then I'm going to assign it a value of false. And then another thing is going to be really if we find one number, so even one number is enough to find that really fulfills this condition here in order to say that our number is not prime number. And in that situation we do not really need to check any more numbers because we have determined that our number is not prime number. So here I can use break statement, so I can say if you find only one number, please do not iterate through this for loop anymore because we do not need to find any more numbers. So in this situation here we have iterated through all the numbers between 2 and that number that our user has entered. We have checked whether that number can be divided by any value of our I counter, and if it can be divided, meaning that it gives the remainder of 0 after that division, we are going to set our prime flag to false, and we are going to break from our for loop. And after we have successfully fulfilled this, so after we have successfully iterated through this for loop, or we have fulfilled this condition in one iteration, we are going to leave our for loop and we are going to come to this line of code here. And here I want to check what has happened with my isPrimeFlag, meaning I want to check whether this isPrimeFlag has stayed true, which means that our for loop has executed all of its iterations and it has not found any number that can be really used to fulfill this condition here. And in that particular situation, that flag is going to stay true, and that is going to mean that our number is prime number. So here I'm going to write out if is prime flag, meaning if this value here, if this variable here holds the value of true, we are going to write out cout like this, and we are going to write out prime number like this, okay? And let's also add end line here. But in a situation where this here does not hold a value of true, that means that in one iteration, so it can be the first one, it can be the last one, it can be any in between, we have really found at least one number that can be used to fulfill this condition and that has set our isPrimeFlag to false. And in that situation we are going to use our else statement, and we are going to copy this and we are going to really modify it to say not prime number, like this. Okay, so now if I run this program, you can see that it asks us to enter a number. I'm going to enter a number, let's say 5, for example, and it says that 5 is prime number, which is correct. 5 is a prime number. And let's run it one more time. And let's say that we want to check 6 this time. And as you can see, our program has written out that 6 is not prime number. And 6 really is not prime number because it is divisible by 2 and by 3, besides from 1 and itself. Okay. So now you have seen how we can really solve this problem. And let's try to refactor this program here in order to use functions. So how we are going to do that? Well, the first thing that we need to do is we need to create function, and I'm going to do that here. And since this part of code here, this is the part of code that we are going to move to our function. And since this part of code here determines really whether our number is prime number or not, and then sets this flag to true or false, let's say that we are going to create a function which is going to check as well whether the number is prime number or not, and then it is going to return a value true or false, meaning the number is prime number or the number is not prime number. And that we are going to write here. So here I'm going to put the return type of my function, and that is going to be bool. So that is the return type of my function. And then the name for my function is going to be is prime number, like this. And then let's say that we want to pass an argument to that function, and that argument is going to be of type int. And that argument is going to be really the number that we want to, check. So we are going to pass the number to our function. That function is going to, in this body here, check whether that number is prime number or not, and then it is going to return bool value, meaning true or false. So if the number is prime number, it is going to return true, and if the number is not prime number, it is going to return the value of false. And how we are going to do that? Very simple. So you see this code here. I'm going to comment this code here, and I'm going to really, no, I should have copied it before. So I'm going to copy this code here, and I'm going to move it to my function. Okay. And we have previously explained this code here, so we do not need to explain it again. But what I'm going to say here is after this algorithm is done, so after we have really stored the value of true or false, so we have stored the value of false in our isPrime flag, or we have really kept this true value inside our isPrime flag, what we need to do is we really just need to say return isPrime flag, like this. So after we have checked whether our number is prime or not, we can really just return that value from our function. Okay, so we can now, after we have moved this code to our function, we can delete it from here, like this. Okay, and then as you can see, we have been left with this isPrime flag, which is not declared now. So identifier isPrime flag is undefined, meaning that now we have to really declare it, and we have to assign it a value. So I'm going to say here bool is prime flag, like this, and then the value that I'm going to assign to my isPrime flag variable is going to be whatever value our function returns. So here I'm going to say please call my function is prime number, is prime number, like this. Okay, and then pass to that function this argument here. So our function expects a value, and that is going to be this number that we want to check whether it's prime or not. And then after this function here is done, it is going to return a value of either true or false, and that value is going to be stored inside our isPrime flag variable. Okay, so now if I run my program, you can see that it asks us again to enter a number. So I'm going to say let's check number 9, for example, and it says that number 9 is not prime number, which is not, because it is divisible by 3. And let's check number 13, for example, and 13 is prime number. Okay, so after we have really used this function in order to perform this particular task, I want to show you one more thing, and that is going to be how we can refactor this function here in order to make it even more simple. And if you look at this function here, you can see that this isPrime flag is set to true here. And then in this situation where we find number that can be used to fulfill this condition here, we set that isPrime flag to false. And then we use this break statement in order to break our for loop. So we are not going to iterate anymore through our for loop when we come to this break statement. And then we really go here and then we return that isPrime flag. But we can do that in a more simple manner. And that is going to be really here. So here, in a situation where we find number that is really fulfilling this condition here, we can say at this very line of code, we can say return false, like this, because this code here we can delete. And why I can use this return statement? Because this return statement is going to really break our for loop, and it is going to return the value from our isPrime number function, meaning it is going to do two things. So we do not really need to set the flag and then return the value of that flag at the end, but we can really say if you find any number that can fulfill this condition, return false immediately. So break for loop and also return the value from our function, meaning end the execution of that function because we have found our result. And then here as well, we do not really need to declare this isPrime flag to true and then return it because it is clearly true. So we can say here, return true, and then remove this flag from here, like this. And then as well, I can remove these curly brackets and make my code even more readable. So now I want to explain what we have done. So here we are passing a number to our isPrime number function. Then we are iterating through all the numbers between 2 and that number. We have skipped 1 and that number itself because all the numbers are divisible by 1 and by that number itself. And then we are checking whether any of these I values between 2 and number fulfill this condition here. That would mean that that number is divisible by that current value of I, and that would mean that our number is not prime number. So at that very moment we can say please return false because this number is clearly not prime number. But in a situation where this for loop has really iterated through all of its iterations and it has not found any number that fulfills this condition here, that means that this return false statement has not been executed. And then in that particular situation, this return statement here is going to be executed, and this return statement here says return true. Okay, so this part of code here has not changed, nor it is going to change. And if I run it again, you can see it asks me to enter a number. I'm going to enter number 7. Then it is going to check whether that number is prime number. So it is going to call our function and assign the result of that to our isPrime flag variable. And I press enter here. You can see that we get the result prime number because 7 is prime number. Okay, and that is really making your code much more readable and reusable as well. So this main function here is much more clean than it was before. And now I want to show you the most beautiful thing, and that is going to be how we can make this isPrime number function reusable. So let's say that I am going to delete all of this code here. So I'm going to delete it. And now I know that I have written out this isPrime number function. And I know that I can really invoke this function and use it whenever I need to determine whether some number is prime number or not. So let's say that now we want to check all the prime numbers between 1 and 1,000, for example. So how we are going to do that? Well, we are going to iterate through all the numbers between 1, so I is equal to 1, and then I is less than or equal to 1,000, and increase our I in each iteration by 1, like this. And then in each iteration, I really am going to just send this I to my function, and I'm going to really get the result from this function. So this function is going to tell me whether that I is prime number or not. So here I'm going to declare a variable of type bool, and I'm going to call it is prime, and I'm going to assign to that variable a value of is prime number when I pass it the value of I. So whatever this function here returns, whatever this function here results in, I'm going to assign that result to my is prime variable. Okay, and now what I want to write out is all the numbers that are prime numbers between 1 and this 1000 value. So I'm going to say if is prime, like this. I'm going to write out cout, and then I want to write out the current value of my I counter, because that is the number that we are talking about. So I is prime number, like this. Okay, and I'm going to add a new line at the end. So this code here is really going to check all the prime numbers between 1 and 1000, and it is going to write out all the prime numbers in that interval. And for solving this particular problem, so whether the number is prime number or not, we have used this is prime number function, which we have written once, and we have really tested it once. We know that it works as it should, and now we can really close it. We do not need to really think about how we are going to perform this task, never again. So we have written it, we have tested it, and now we have this algorithm stored in our is prime number function, and we know that this function works in a following way. So we pass it a value, and then this function returns us true or false variable, meaning that the number is prime number or not. So once more, if I run my program, you can see that we have gotten the expected result. So we have gotten all the prime numbers between 1 and 1000, okay, and there are a lot of numbers, okay, so you can check these numbers on your calculator if you want. And let's say now that we really want to check all the numbers between not just 1 and 1000, but let's say 1 and 10,000 or 100,000, okay, we can call just this is prime number function, pass it the value of our I, and then check the value that this function has returned. And this function has really told us whether the number is prime number or not, and if the number is prime number, we just want to write that number out to our user. So if I run this function again, you can see that it is writing out all the prime numbers between 1 and 100,000, and there is a lot of numbers again. So you can even count how many prime numbers there are in this interval, so between 1 and 100,000. And let's say that I'm going to leave that part to you. So if you want to really upgrade this program so that it counts how many prime numbers there are in this interval, you can write that code in the comments down below, and I'm going to check it, and as well you can leave it for other people to see and use if they need it. So I hope that you have understood this return type of a function, and in this particular situation it was bool type, but you can have as a return type from your function, you can have any other data type. So you can have float, char, int, string, whichever data type you can really use in order to create a variable. You can use that data type in order to be a return type of your function. So in this particular situation, I wanted to show you an example of a bit of a more complex function, let's say, that is going to determine whether your number is prime number or not, and it is going to really receive that number that you want to check as an argument, as parameter, and then it is going to return only true or false, meaning that number is prime number or that number is not prime number. And once you have written this code and once you have tested it, you do not really need to bother with this function anymore. You do not need to remember this code, nor read it, nor even understand it in order to use this function. Only in a situation where you have a bug, and that bug is in this particular function, only in that situation you are going to need to really reread this function and fix that bug. In any other situation, you can really just use this is prime number function. And as well, we could have made other functions with other return types. We could have created, for example, a function that is going to sum two numbers. So you are going to pass to a function two numbers, let's say number A and number B, which your user enters, and then that function is going to sum those two numbers, and it is going to return the result to your main function from where you are going to invoke that function. And as well, I can leave that to you, so you can really practice writing functions on that example, for example, and you can put the code for that exercise in the comments down below as well, and I'm going to check it. And in this particular example, as I said, I wanted to show you a bit more complex example so that you can really understand why we need functions and why they make our code understandable and reusable. And if someone else comes to your code now and he sees that he has isPrimeNumber function, he does not really need to open this function and read how this function works. It is pretty clear from this declaration itself that this function receives a number and determines whether that number is prime number or not, and returns that true or false back to the invoker, back to the function that invoked this is prime number. Okay, so I hope that you liked this video. I hope that you enjoyed watching this video. If you did, make sure to like it and also subscribe to my channel and follow me on my other social media, so Instagram, Twitter account @CodeBeauty. The link is going to be in the description, and I'm going to see you in my next video. Bye.